We didn't even have a bathroom in our house. So I remember you'd have to like walk, for, I don't know, 10, 15 minutes to go to this kind of dump area. That's what I remember.
Durender Donkwa grew up in Ghana, a place where malaria is tragically very common.
Everyone in my family have had malaria. When I decided to actually study malaria, my mom was like, why are you studying the fever? Because it's so common and she thinks that it's the common fever.
Durender knew early on that she wanted to do something to help, and now she is a research technician at the Center for Infectious Disease Research.
Here what we have is a blood infected with malaria parasite, and this is how it looks when it actually infects a red blood cell.
Durender is part of a team working on the development of an effective vaccine designed to specifically prevent the form of malaria that is plaguing many parts of Africa. Malaria is a disease caused by a parasite transmitted to humans by infected mosquitoes. According to the World Health Organization, in 2015, it put nearly half of the world's population at risk. Symptoms of malaria include fever, chills, headaches, sweats, fatigue, nausea, and vomiting. In some cases, it can go to the brain and cause seizures and other mental deterioration, and ultimately, if untreated, death.
So what we're trying to do is to stop the parasite from actually going to the blood from the liver. And if we can stop the parasite in the liver and expose you with that parasite, you're actually going to get immunized to it. So maybe the next time when you actually see the parasite, you're going to be resistant to it, and that's how we're trying to develop immunity towards it. I can feel them now.
Sebastian MIKOLAJCZAK's team made a breakthrough that was recently published in the journal Science Translational Medicine. They successfully genetically modified the parasite and were able to expose study participants safely with no side effects.
The idea here is to allow the mosquitoes to probe your arm as many times as possible.
In an earlier study, one participant got malaria, so they modified the parasite even more for the latest trial, and it proved to be safe. Eventually, participants will receive the vaccine from a shot, but they're not quite there yet. So the participants received the vaccine through hundreds, yes, hundreds of mosquito bites.
But there's definitely few bites you can see here when they're probing.
There is a current vaccine, but researchers say it's only 30 to 50% effective. They want the new vaccine they've been working on for more than 10 years to be highly effective, to save more lives.
Our approach is to produce it in a different way. Instead of taking a protein, we're trying to actually take the whole parasite, change it, mutate it, so it doesn't make you sick, but it is still the whole parasite. So then when we expose you to that parasite, you have a better ability, a better chance of developing the right immune responses to it.
So to really understand malaria, you have to go back to the life cycle of the parasite. And it's one of the most complex life cycles of any single-celled organism on the planet.
The Center for Infectious Disease Research is part of a coalition housed at Fred Hutch called the Seattle Malaria Clinical Trial Center. The University of Washington School of Medicine is also part of the team. They're working hard to develop effective and safe vaccines, as well as medicines to better cure and treat malaria. The current medicine is expensive, and malaria is starting to become resistant to it.
With malaria, we can infect people, cure it as soon as we detect it, and therefore understand and assess vaccines and drugs in a very rapid timeline compared to some of these other infectious diseases in which it takes thousands of people over 4 or 5 years to conduct a similar study.
They couldn't make these important discoveries and move treatment options forward if it wasn't for study participants, some who took part in a recent study where they were actually given malaria and then treated with an experimental drug.
It's kind of crazy, who would go get malaria voluntarily, but it is pretty cool to think about the bigger picture and the bigger cause and the fact that we really could be making a huge difference for millions of people around the world who get malaria every day.
They gave me a drug, and then we actually got bit by mosquitoes. So it wasn't the intravenous, and then saw what happened, and I got malaria.
And just like Durender, you could say malaria is also very personal for JOELLE MUMLEY. She grew up in Kenya and saw both loved ones and friends get it. She plans to go back and wanted to help make a difference.
I never got malaria, but it was something that was kind of a regular reality in people's lives, and so I was both aware of malaria and also not very afraid of getting it, because I think at some point in my life I probably will get it being there. And so I felt like I was in a unique position. A lot of people are really scared of the idea of getting malaria, and I just wasn't as intimidated by it, I guess.
Thanks to the many researchers and study participants, Seattle is one step closer to creating a more effective vaccine and treatment options to hopefully one day be able to put an end to the suffering and deaths.
Having people volunteer gives us the opportunity to really understand whether or not these drugs or vaccines will work for the millions of people in desperate need of improved treatment, therapy, and prevention.
I hope that we can create an effective vaccine. It would be amazing to see that, to think about family members in Ghana that, could eventually receive this vaccine and not have to worry about, staying home from, work, which is already difficult to find when living there.
Watch CityStream Thursday nights at 7 on the Seattle channel, or get video on demand and podcast anytime at seattlechannel.org.